Okay, I think we're recording again. I hit the wrong button, and so I stopped it instead of paused it. So let's try this all again. Negative 2 is the answer to number 1, and the reason for that is that if I start at pi and go to 2 pi, now we are below the x-axis, and so that's going to be a negative area. But it's the same type of area. It's kind of a symmetric kind of idea, so if you can kind of visualize that a little bit. And then number 2, going from 0 to 2 pi, that's going to have 0. I have a positive 2 above, I have a negative 2 below. Those two things are going to cancel each other off, 2 minus 2. Yeah, so that's with that slide. So bring some questions on that if you have it. We will work on that exploration a little bit when I do see you next. Here's just a quick diagram. I think this is in your book somewhere of Riemann sums. You can see that those intervals aren't necessarily all the same width to approximate the area under a curve. So that's a Riemann sum, just to kind of sum that all up a little bit. Real quick, the definite integral of a constant. Let's think about that for a moment. And I think this is also probably a diagram that's in your book somewhere too. But this constant, you see that same integral notation. Here though, f of x is c, so f of x could be 2 or 5 or negative 10. Well, what does that mean? What does that look like? Well, that constant is just a line that's drawn across here. And the AB, that's the interval, so maybe 2 to 5. Well, how do I find the area under the curve? Well, if you think about that, hopefully you're saying, oh, that's just a rectangle, length times width. Well, to figure out the width, you have to take b minus a, so that's what that is, and your height is just going to be c. Down here, your height, though, is now a negative c because we're below the x-axis. So let's do one of those problems. This problem is found on page 282. It's question number 7. So let's think about what that looks like, and I can draw just kind of a rough sketch of it here. Here's my xy axis. Here's y equal to 5 going across here, if I keep my pen on the page. All right, and I want to go from, oh, I didn't do this very well at all. Let's try this again. From negative 2 to 1. Okay, so I can kind of sketch that in there, and I want to find this area. How do I do that? Length times width. Well, the width is 3, the height is 5. We know that b minus a times c. All right, hanging in there on that one. You got a couple problems like that today. And the very last problem that we're going to do together today is number 13 on page 283. And the directions on this say use the graph of the integrand in areas to evaluate the integral. So something that you should probably do on this particular section is to graph it and look at it. If it helps you to graph on your calculator, you certainly can. If you want to just make a rough sketch on your paper, you certainly can. And again, I'm not drawing very to scale here. I know I have something about negative 2, and I know I have something about 4. X over 2 plus 3, that plus 3 is going to be that y-intercept. This isn't, again, very to scale, but here it is. X over 2, 1/2 x, you might think about it like that. So I'm going to have a slope of 1/2. So something maybe about there. And again, here is my area. And there's probably a couple ways you can think about that. One way might be to think about that area under the curve, between the curve and the x-axis, is to be a trapezoid. So let's think about it as a trapezoid. Trapezoid is 1/2 b1 plus b2 times the height. And the tricky part here is your b1 and your b2 are really on the sides, the negative 2 and the 4. The height is really the width, if you will. 4 minus a negative 2 or 6. So we just end up just kind of number punching that and coming up with an answer. So that wraps up section 5.2. And so hopefully this works out pretty slick, and bring some questions on whenever I see you next. The assignment is also posted on the website. I think that you'll be okay to get through some of that, and bring questions. We'll certainly take time to answer them. All right, good job.